Hi guys, I thought today we talk about multimeters. I just took delivery of a new one, an O1 XEM1041, which we want to put through its paces and see what that's like. It's a desktop one, and I will insert the unboxing of the O1 multimeter right now. So let's have a look what we've got. O1 XDM1041 USB digital multimeter, 550,000 counts, high accuracy universal desktop multimeters, meter with 3.5-inch TFT LCD screen, US plug. Okay. Anything else in there? Power cord. Some of these useless crocodile clip thingies that I never use. You'd have to be a bodybuilder in order to open these clips up. They're so stiff. USB cable. So it should be able to be plugged into the computer. We'll try that out. Test. It's these chunky ones that are not very good for more components, but we've got better ones, so that's fine. Out of the bag. What else is in the box? Just the manual. Okay. Spare fuse. 250 volts, 1 amps. What's this? Specifications. The usual safety stuff. Measurement limits. The note there. Front panel overview. One is an LCD, no kidding. Menu selection keys. Measurement keys, volts, amps, diodes, and continuity, capacitance, frequency, temperature measurements. input terminals. Okay. Primary function reading. Just having a look if there's anything here that I should know about. So it's got a temperature measurement feature, but they didn't include a little probe for that, by the looks of it. Okay. I'm just wondering what software this is compatible with. Auto record, manual record, data record function. Okay, so that comes up on the display like that. I'll have to have a look if I can work out what software this might be compatible with. I can run this software. There we go. I'll put it here on the screen, and when I go in here and I say control connect, comes up with this little box here, and it actually it says via USB, but that's not for this particular model. You have to go via a COM port, and the defaults are correct, so I can say OK, and there it is. It's connected now. And one thing that I found that I've been able to do is to here in OBS Studio is I can actually, I'm gonna turn the display capture off for a sec. I can actually, you see in the top right corner there, I've put in a little window capture there, and if I reduce the size of this window here, I just get in the top right corner, I just get the display there. In actual fact, you have to push this button here to give local control. So to see amps, ohms, nanofarads, and so on. Anyway, so I thought I'd just show where this software comes from and how you can install it, just in case, because it is not in the manual, and you have to find this out by yourself. So if you go to the website here, www.owon.com.hk downloads, if you just do a search for O1 multimeter, you'll end up here. But I click down onto the download, and that is where it is. So I said digital multimeter, and I want software, and then you'll see the 1000 series digital multimeter. So you can actually click on that little cloud here, and it will actually download it. I'm not going to download it because I already have, but it comes up with the XDM PC software. And it's a zip file, and in that zip file you'll find a PDF file which you can follow to install the drivers. I think it was originally done for Windows 7. It's a little bit different on Windows 10, but I was able to work it out from there anyway. So there's a whole bunch of drivers that it installs. So once you've done that, then you will have the the software, and I put it here on my DMM Easy Control is what it is called, and that works that way. So I thought that might have been of some interest. So now I'll be able to use that when I do projects and I want to discuss, you know, or if I'm doing repairs, I can discuss voltages and so on, and I can just have the little display on the screen. I won't have to put the camera on this device to show the what's going on. So I thought that might have been of a little bit of interest there, so I'll put that in. Okay, so we're going to have a look inside of this O1 digital multimeter and see what they've got in there. Okay, so we have this is the power supply and the USB module in here. We'll look at that in a second. This here is a two little printed circuit boards, one on top of the other. One is for obviously for the buttons and the display, and here I guess there's not much to it. Okay, so I did find some temperature probes that came with my other multimeters. This is one of them, and I got one plugged in, identical. They have a little thermocouple at the end here, and right now it's reading 22.9 degrees. I'm going to touch that little heating unit here that is for the T, and as you can see it's counting up. Should be, with nothing on it, should be roughly 100 degrees C. Or close to it. 90 degrees. Yeah, that's about right. Turn that off. So should be able to use this to measure my temperature on my soldering stations there. I'm going to do some videos on my soldering stations, and over here, if you look at my other videos, this is one I built recently, this one there, and I haven't calibrated it, so we're going to use this and see if it'll work in order to calibrate the soldering stations at some stage. We'll do a video on that as well. Okay, so it seems cheap that they didn't include it's got a temperature feature, so why didn't they include a temperature little temperature probe with it? I mean, how much does a little thermocouple cost? The unit here costs about $125, I think. Let's have a look. One here. And I paid a little bit less for it than that. Things are going up every day by the looks of it right now, but I think I paid $125. But you would think that they would include one of those little temperature thermocouple things with it, like everyone else does, but they didn't. Anyway, we'll leave it at that for now, and look into these things a bit further later in another video. Okay, so we can test some of these things, but let's start with these little ones first. I've got some components here that we can test it on and see how they work. This one here is actually one of my favorites, surprisingly. It is a little pencil type, and it is quite good. It comes with a nice needle-like point. It came also with a crocodile clip that it plugs into the back, and it has a probe that came with it as well that you can actually plug in, which is over here. Also with a needle like so, you can point on it, so you can actually measure, you know, like point to point, or most often, you know, I use this thing, I connect that to ground, and then you can connect test voltages. It has a facility for most modern multimeters have. It has an auto mode. It goes DC voltage, AC voltage. This push the button here. Capacitance, diode mode, continuity mode. It has temperature measurements, which I don't know, don't use. Frequency in hertz, and it has a button here where you can actually go near a power. You'll probably see that. See, when there is power, this cable here is connected to the, it shows green, that's live, and if you get really close to the bit that has the actual, that's the live, like if it's a power outlet, it goes red. So it is really effective at that. So it's good for that as well. we'll have a look at that in a minute. Compare it, you know, on accuracy. So that is that one. This one here is a special one that I use. It has little tweezers on it. It's good for SMD components. It did come with little probes. Never used those. The probes would plug into those little holes here. I don't use those. I mean, yeah, I've got other multimeters with probes, so why would I use this one? It is interesting. It has a resistance, diode and capacitance mode on one switch there. Then you can switch it to the end there. You can actually test batteries with it, or power. But if you press function here, leave it in that mode, press function here. Right now it's set to auto and resistance, and this is capacitance, this is the diode mode, and vector resistance. And if I flick that little switch here, now it is DC voltage, and I think that's the only voltage that it has, because of its type. This is again DC voltage. So with this particular one, let's have a look at set for resistance. Let me find a resistor here. See, there's a tiny little resistor here, and I guess you can't see it, it's off the microscope here, but it says it's 9.9 ohms. Not quite read the resistance on there, but in any case, that's kind of how you can use that thing. And of course, it's got capacitance. Let me have a look here. This is capacitance. There's a capacitor there. How about this one here? Just thinking about it. 221 nanofarads. So that's how I use this thing occasionally for testing in-circuit components. So that's kind of, it's kind of a useful little thing to have. But we will put this one aside. I'm not going to bother to include that in our test for accuracy, because this thing here is a one of these cheap Harbor Freight things that I used to give away some years ago, and I only use this thing if I'm measuring something which might be potentially harmful. If I'm not quite sure what the voltage is or something, if I blow this thing up, it's not worth anything. And so again, we're not going to go into too much detail with that, because these things, they have limitations, and since it was free anyway, so now I don't think Harbor Freight has any more free stuff. They probably sell it for $10 or something. Okay, so then these guys here, they have let me untangle all these probes here. They have dials on them. This is, 40 years ago or more, this is all you would be able to get. And there's a big one here as well. This big one here is way out on some of the measurements. Like I was measuring 5 volts with it yesterday and set 4.2 volts. Probably some resistors or something in there. It's got some internal, the resistance has changed or something like that. So I must have a look at it at some stage. So what do I use these things for? Very, very occasionally, if you are testing a circuit that has you want to measure resistance or something like that on to see if there's a short circuit on a power bar or something, and there's a bunch of capacitors there, especially with modern circuits that have a low resistance but lots of capacitance, like with MOSFETs on them and so on. You can see on a digital multimeter, and we might even try that out later on, the count keeps changing, and you have to hold it for quite a while, and until you get a real reading. And sometimes too, you can get readings on digital multimeters that it goes back and forth. It's not stable, and it's hard to interpret what the average is that you're actually reading. It goes back and forth, whereas on one of these old-fashioned meters, the dial just goes, it's got some weight to it or something. It smooths things out, so you will see the needle. It might fluctuate a little bit, but it gives you a feel what the average is, much better visually than what a digital one does. So occasionally I will have a use for one of these things, and I will use it. We'll have a look at this later on. This Micronta one from Radio Shack actually still appears to be accurate, even though it is old. So anyway, beside the point. So there is also some specialized multimeters. For instance, this one comes to hand first. This is a well, as I've zoomed in, I can't put all the multimeters back in the screen very easily. Okay, there we go. This is actually a milliohm meter. Comes with a little cover thing, and it is kind of special, very useful for trying to trace short circuits in motherboards, with these VRM MOSFET circuits on them and so on. You might be able to determine where a short circuit is, and it might only be 0.1 ohms or 0.01 ohms, like a 10 milliohms, or even 2 milliohms difference between the getting close to the short circuit and when it got multiple phases and so on. you can actually see where the lowest resistance is, and that is usually the one that is shorted or something like that. Comes with these Kelvin clips, which are nice, and it has a special circuit here. I think I discussed that before in one of our other videos, that actually the two tips on these probes are actually connected individually to those wires. One inserts voltage and the other one actually measures the voltage right at the tip, so therefore the resistance of these actual cables can be negated out and calculated out. So that is one that I tend to use. And then there is this thing here, which is an insulation resistance tester by the same company, and it is kind of a specialized multimeter. You can measure ohms with it, but it has a capability of measuring very high resistances, and it can measure voltage, 1000 volts, 750 volts, which is what most of the other multimeters can do. But it actually generates up to 1000 volts to test insulation resistance. So if you've got a circuit where you have like on one case I had a circuit where there was a inductor very close to it was badly designed, very close to a heatsink, and the inductor was actually pushed over and it was touching the heatsink, and the wire of course only has a little bit of like a resin varnish on it, and if you measure the resistance there, it would flash over at even less than 1000 volts. So that was kind of a dangerous circuit, and this is the kind of thing that you would use in order to determine that. If you build a circuit that has 120 or 240 volts in other countries circuitry on it, or other high voltage sections, then before you release it to the wild, you would use a device like this in order to test it from ground and so on, and make sure that there is no leakage anywhere or any dangerous parts of the circuit. But we won't go to, we might do a video on that at some stage. This one here is also I bought recently, and it is actually it can work as a little multimeter. It has probes that come with it that you can plug in, but the only reason I got this is because sometimes it's inconvenient to measure current in circuit. With most of these multimeters like this one here, you will find that you have to plug the leads into a different socket, and then you have to go and connect that in circuit with what you're testing, and this can sometimes be inconvenient. And these kind of things have a clamp that you can actually clamp onto a wire that is conducting the current into your circuit. I wonder if I can show this. Just hold on for a second. Okay, I've moved the camera over here. I actually have my power supply here warming up my tea, and this wire over here would have some current on it. So anyway, let's unplug these probes, makes it a bit easier. I'm going to set it to current here, and I want to set it to DC current, and zero it out because it picks up, and if I put it over here, it actually says 1.938 amps DC. If you can see that there. And this particular one, now according to the little dial over here, it actually says it is like 2 amps. So that is quite accurate. That little dial there, I know, is not that accurate, so I'd rather trust this thing. Okay, so I would rather trust this thing than the dial on there. This is why I have that. It is very convenient, and this is one of the few that I know of that can actually measure right down to the millivolt level. When you get old-fashioned ones, I have another one somewhere else. I have more multimeters than what I have here. I don't even know where I put it. This is an old-fashioned clamp one. It actually has a dial on it, and these things only work, like I says, AC amps, 6 amps, and I don't even think it has a DC mode at all. No, it doesn't. It's only AC. It does have a 60 volt DC voltage, but it has, you'd have to plug probes into it. Most of these things are made for the heavy wire guys, electricians and so on, and they measure high currents and mostly AC currents. But this thing here is suited for us electronics guys, and so that's why I have this one. It is quite a nice little unit, made by Unity, and comes with a little pouch. This one here is another cheap multimeter. I think I bought it last year sometime, or 2 years ago, I can't remember. I seldomly use it. It's not very accurate, and it does have some backlight, I think. Yeah, there you go. It has a backlight on it. It works okay, but as I said, it's not that accurate. I've actually got it connected to one of these things. Comes with some of those probe kits. It's like it has a plus sign over here and a minus sign there, so it's negative, positive, so you can go and test certain components that in circuit. This is not an actual use case for it. So that's that. Oh, better touch this button to turn it off. Then there's this one here. I also bought this at Harbor Freight. This one actually is a really sturdy one. It has a rubber case around it, and it has the feature that I don't like with one of these controls, but nevertheless, this is one that I use if again, it comes with a pouch and everything, and the actual probes that came with it, they clip in the back here, like so. So this is handy, like if I'm doing electrical work. This is the one that I will use, which is kind of what it's designed for. The only interesting thing is that it has a low Z setting, and it actually has a lower impedance when it's testing. The normal impedance is like a couple of mega ohms. This is like 130 kilo ohms or something like that. I'm not sure where exactly that is used for, but some of you guys might know. You can put in the comments. Possibly this is important to people that do air conditioning, motors, electricians, something like that. I'm not sure. It is not particularly 100% accurate. It's accurate enough, especially for electrical work, but for electronics, like you might find 4.94 volts instead of 5 volts or something like that. You know, it's typical for these, and this thing is the same. Okay, so let me get the other camera going. Okay, so let's have a look at what we can do with this new multimeter. I've got the probes connected together, so it says 0 volts DC, and I've got my little power supply in the background there set to 5 volts, at least if I push the button there, and it's a digital power supply which is actually quite accurate. So let's hook it up. And we got 5.0044, which is the power supply only has 2 digits behind the decimal place, so this is it varies depending on temperature. I've noticed a little bit, which is quite accurate. Let's hook it up to my other accurate desktop. Well, it'll be using different probes here, but I will get, that means that they will get a little bit of a different reading, because I don't want to substitute the probes. And let's bring it in. According to my other benchtop supply, it is 5.0054, and as I said, these probes have a little bit more different impedance, so if I use the same clips, it might well be almost the same. .0045, and it's only 5 millivolts difference, so these guys are quite accurate. Now if I measure it with some of these other multimeters here, it will show. In this case, let's use the same probe so that there is no difference. Hook them up. 1 and 2. There, you see what I mean? 4.997. It's just not as accurate. It should be 5.00 something. Not that it is out by much. I mean, if you're using this on as an electrician and everything, if you are 5 millivolts out or something like that, you wouldn't even care. But it's a test. This thing is similar, I believe. It's even worse. 4.984. So this one is quite out a little bit. It's probably 20 or 30 millivolts out. So that's why these bench power supplies, they are bench multimeters, they are way more accurate, and they have conveniences. They don't turn off, and as you'll see, it'll have other things, features that are very useful. Now we're curious about this old dial one. Let's set it to well, it actually has a 5-volt range, so let's set it to 5 volts. Not bad. It's just a smidge, like a hair over 5 volts, not even a hair over 5 volts. The 5-volt range, you see that? Because depending on how you hold it, you know, it should be flat if you want to be accurate. So that's, which begs the question, if you put it on the 25-volt range, again we've got 5 volts. I mean, this one has retained its accuracy over 40 years, so it's actually okay. The only problem with these kind of dial types is that the ohms range here, it can only do, you know, not much more than like it says 2K is there, and if you go to the highest ohms range, it is where is it, times 1K, so that is 2 megohms. But even between 2 and 3 and 4 and 5 megohms, 1 meg, it's very little difference, so you can't really judge it from there. So the ohms ranges in these old dial ones, they have limitations as to high resistance accuracy, and low resistance is better, because you see the dial actually gets wider when you get to the low ohms range. In any case, that was just for interest's sake. Where's off? We'll put this one aside now. These old multimeters, they don't do anything else other than ohms and volts and current. They're not like the modern ones. Oh, and then there's this one here. Let's have a look what this one says. I suspect that a lot of these things uses the same circuit. This one is not too bad. It's actually quite good. 5.003. You see, it's missing a digit. So if it has 5.0025 or 6 or 7, it would round it off to 3. So it is this one too is accurate. As I said, I like this little guy a lot. I use it. I reach for it all the time. I use it in preference of my other multimeters quite often. Okay. Now, what else can we find out? Turn the power supply off, because I don't need that anymore. I've got some components here. Let's try resistance. Now let's do something interesting here. Let's get our milliohm meter. I'll just temporarily zoom out. So this one here needs a power supply. I think this is the one that I use, yes. I don't tend to put batteries in these things. I don't use it that often, and batteries tend to go bad. And if I use an external power supply, then I don't have to worry about that, and it doesn't have to turn off either. Let's set it for 2 ohm range, and 1, 2. Now the first thing you do with one of these milliohm meters. I can get these wires untangled. Is to zero it. So you put the clips together like so, and well, it's already set to 0, so that's fine. And I've got 4 1 ohm 5% resistors here, and we got a 0.255 ohms according to the milliohm meter. This thing is accurate. So now when we everything gets tangled up. You think I could arrange this a little bit better? Okay. So let's set this to ohms. Now the first thing to do also is to so I got this connected together, and as you can see there's a little bit of residual there, so you can actually say relative like so. So it'll that's the one thing that you want to look for if you get a benchtop multimeter, that it has that facility. And 0.25 to 0.6, it is accurate because the milliohm meter showed it was 2.55, so that will, you know, count up occasionally to 2.6, but it is not as accurate obviously as a wait a minute, let me try something else here. This thing has a range feature. It says range auto. Let's have a look. Is that the lowest it goes? 500 ohms. I guess. Because the rest is megohms. So yeah, it looks like you get at least 2 significant digits, but it is accurate nevertheless. Let's have a look what my other desktop multimeter has. Now, as I said, I've got different probes here. These probes are not as good as the ones I'm using. It doesn't have these Kelvin clips and stuff on there, but nevertheless, let's have a look. Again, you see ohms, just one button to push, none of this click 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 stuff. Okay, you see we got 0.5 ohms, but I didn't zero this one, so let's touch the probes together. And now again, this one has a relative. There we go. And see, without that relative mode you cannot do an accurate measurement. 0.25, 0.26. Yeah, it's just as accurate as the O1 one. Even through these probes, because we have this relative setting, we can actually get rid of the resistance of the probes that way. Turn that off. Very good. So I don't know if any of the other multimeters I have this feature going relative. I don't think they do, the cheap ones, and even the more expensive ones. Only the desktop ones do. So a bench multimeter, you really need one of those. I would buy a bench one before I bought one of those cheap ones. What else can we do? Let's have a look at high resistance ranges, like in the megohm area. What have we got here? I got two resistors here that are, one is 10% and one is 20%, or they're very old, very old. I've had these things for 40 years or more, so I don't know what their resistance is going to be. Let's turn this thing off and get rid of that, because we're done with the low voltage stuff. And get that out of the way. Don't need this anymore. Let's try this one first. What is this? Green, blue, green. And that is 5.6 megohms. As I said, this is a very old, and when it was new it's got a silver band on it, so it would have been 10%. But you see, I've got it on high speed now, and so that can be quite confusing when it updates it so quick, and each reading is slightly different. So putting it on low speed is actually, it updates 3 times a second at low speed, is actually more convenient. In any case, we've got 5.9. What does our little guy here say? Five point seven. Those legs on there are very corroded, so we have to squeeze pretty hard. 5.803 it settles on. It's actually a little quicker to come up with a oh, measuring the wrong one. $5.84839. It seems to be coming back quicker with a maybe a slightly more accurate reading. $5.9. Really badly corroded legs on it. I wonder if I can use a rubber on it and shine it up a bit. So what does this say? This says brown, black and blue. Brown, black and blue. Oh, this is true. This is like supposed to be 10 megohms. And it's reading 11. It's a 20% or so. About 11.8 something, 11.9. I think that is out of range of the other multimeter, because it is not showing anything. You can do that one. Interesting. It's just not reading anything. I don't suppose there's a... Oh, I had to change the range, that's why. That's a bit inconvenient, and that one is confusing because it says mega ohm. And it's telling me 11.76. So the other one, the Vichy one there, it comes to a conclusion quicker and it is more steady, which is actually nicer. This one just keeps on changing a lot. Can this little guy measure that high resistance or not? Yes, it can. 11.76. Surprisingly accurate, that little guy, isn't it? 11.8. What did we get on the other one again? Eleven point 72324. All slightly different, but this little guy and the other bench meter are closer than this one, but I'm not sure. They're all close enough, I guess. Close enough. Okay, so high resistance is a possibility there. Now here we got a Zener diode, 3.3 volt one. So let's have a look. Function diode, it says. Wonder if I should zoom in a little. Okay, that's a bit closer. So we are in diode mode. This is our little diode, and we're going to actually connect it back to front, and we'll get 2.35 volts DC. Says beeper on, beeper off. I don't need a beeper. This is forward voltage, but I know this is a Zener diode, and the reverse voltage, it claims to be 2.35 volts, but I thought it was 3.3. But let's have a look. Let's go to, okay, this is set to diode mode. It also says 2.15. 2.3. Makes you wonder if you can actually measure a a Zener voltage with one of these things or not. They're all different. 2.45. Now, according to my proper tester here, which is meant for that kind of work, says it's a Zener diode, uh, 3.2 volts reverse voltage, which is the Zener voltage. Forward voltage 0.75. So I would rather trust that because it is a proper component tester here. Now here we've got a light emitting diode. .79, which seems low to me because it should be more closer to 2 volts, I think. Well, that one's even worse, 1.68. .78. Also 1.78. So the little one, the one and this one agree. Interesting. Now let's have a look at capacitance. Where is capacitance? Here. Okay. Well, it says 0, so I don't have to turn the relative mode on, obviously. .992 microfarads, and according to the printing on these capacitors at 250 volts, 1.0, so it's supposed to be 1 microfarad. What did we get again? We got 0.992. Okay, capacitance coming up. Where are you here, capacitors? According to this, 1.065, and according to this one, we want capacitors. Okay. .993.1. It's interesting how the little one and this one agree closer. very close. 0.99299 is actually the same. Actually, it's almost like they got the same, sharing the same circuit. I would rather trust these two than the old desktop multimeter there. Let's try a weenie one. .73, 3.4, just over 73 nanofarads. 72.73. Trying to hold it, but if I touch both leads, it changes. Anyway, 72.5 roughly. Yeah, that's about what I was reading on this on the little one. Yeah, they all three agree on this one. Capacitor, like I now see, this is a 6.3, 5,600 microfarads, and you know, I don't know where I got this from and how old this thing is. .054 millifarads. So in other words, over 6,000 microfarads. Yes. Well, this is oh, it's finally getting there. It doesn't like it very much. It's pretty slow to come up with a value on that one. It's getting there eventually. The little one here came up with a value much quicker. 6.06. It's about the same value as that one. Okay. I guess when you go to relative mode on this thing, you lose the auto range. I don't think it is happy measuring that. Interesting. What about a smaller one? Here is an old leaky 1000 microfarad Yes, you can do it. This O1 thing is pretty slow at calculating high capacitances. It does have a very bad ESI, this one. It's a very old capacitor that okay, 1250 microfarads. $12.50. I don't tend to use multimeters much for measuring capacitances because I have proper LCI meters, which is I'm going to do a video on it, so I'm waiting for a new one to come. 160 microfarads, 0.7, and $162.3, about a little bit less than 2 microfarad difference. Okay, well, I think that's gives us a bit of an indication. Surprisingly, this little one is been proven to be quite accurate. Now it also has a hertz setting, and I'm going to let's set it for 10 kilohertz roughly. I've got an old signal generator there that doesn't have a digital display. I do have a more modern one that does have a digital display, but it's harder to set up. Okay, let's have a look. This is actually set for TTL output, so well, look at that, 10.2 kilohertz. It works. I guess there's a good reason why I like that little guy. It seems to be doing everything. Oh, I've got to set this for frequency. Also working. 10.019. This other one's picking up noise. 10.015. Okay, so far everything is working. Let's give it 100 kilohertz. 99.901 on that one. $99.928, 99.9998, So it can handle 100 kilohertz. Okay, what about a megahertz? 1.121 megahertz. It's working. This one's supposed to be able to do up to 60 megahertz according to the specs. Oh, looking up the wrong thing. .12 megahertz. No problems. I suppose that this one will work too. Okay, as a bit of a prologue here to this these videos, I've come to the conclusion that these are the three multimeters that I will use the most often. The O1 one, because I can use it with OBS Studio, and when I'm doing videos and testing and repairing electronics and stuff, I can put the display on the screen, which is going to be convenient. This one, however, has been most impressive, I think. It is very accurate and very convenient. It came with both a lead with a crocodile clip, so you can hook it onto ground, and then you can probe the components on the PCB. Got a nice fine needle on it, so it's suitable for SMD components. It only has one battery in there, so the whole thing is compact and small and convenient. This one over here, of course, mostly if I need to measure current with the clip there, so I don't have to intercept the circuit and make it go, you know, like the average multimeter. You know, if you like on this one here, you have to actually pull the probe out and put it in the amp range, and you have to hook it into the power and all that kind of stuff, which this makes this convenient if you just want to have unless you want to know exactly down to the microamp or milliamp or something what current is being drawn. This one is plenty accurate enough just with the magnetic clamp. So I thought I would just also show you the pentap multimeter. I got it from AliExpress, and this is the one, and I think I paid $19.95 for it or something. You know, the prices vary. If you wait till there's a sale on AliExpress, you can probably get it cheaper, but this is a really good price for only $20. And I said, look out for this one. It has both the crocodile clip. It has both the crocodile clip and the probe, and it only uses only the one battery. And there are other ones that are around AliExpress and on Amazon and so on. They are much more bulky than this thing, and they take two batteries, and they don't come with the crocodile clip, and they look very clumsy and awkward. They also don't have the nice fine needle tip on it, so don't buy that one. Don't get confused. This is the one to get. Alright, so that is what I was going to leave it at. Next we're going to look at some LCR meters, and also all the different soldering irons and soldering devices that I have, and what I use them for coming up. So keep in touch. I'll see you later.